Welcome to this video on Year 1 Mechanics Chapter 8 on modeling. So question 1 asks us to convert 54 kilometers per hour into international standard units or international system of units called SI units. So the units that are relevant to us here are that we need to convert kilometers into meters, and we need to convert hours into seconds. So if we want to do that, I generally advise writing down your initial units as a fraction. So here we have 54 kilometers, and then at the bottom of the fraction, dividing by the hours. And then we convert each of them. So in the case of kilometers, 1 kilometer is 1,000 meters. So I'm going to change the kilometer units to 1,000 meter units. And the hours, there are 60 minutes in an hour and 60 seconds in a minute. So there are 3,600 seconds in an hour. So I multiply the hours by 3,600 to get the seconds. And then if I do this calculation, I get that 54 kilometers per hour is 15 meters per second. Similarly, if we have 12 grams per square centimeter, if we write the 12 grams at the top and the square centimeters at the bottom, to convert grams into kilograms, we need to divide by 1,000. So if you have the 12 at the top, then we put the 1,000 at the bottom. So 12 divided by 1,000 is kilograms. And in the centimeters, to convert centimeters to meter, we need to divide each of the centimeters by 100. But because it's centimeters squared, we need to divide the centimeters by 100 squared to get the meters. So 1 centimeter squared is the same as 1 meter squared divided by 100 squared, which if we have the meter squared at the bottom, means that we have to have the 100 squared at the top. Okay, I hope that's useful for you. So I find it useful to write down the original units, convert each of them individually. If it's a multiply, I multiply on the same place as I am. If it's a divide, if I'm at the top, the factor goes at the bottom. If I'm at the bottom, the factor goes at the top. Okay. Question 2, we need to describe and match some terms with the descriptions. So what is friction? So friction is essentially a force that opposes motion. Or a contact force opposes motion. So B is 1. And then for tension, tension is a force that pulls. Okay, so like a string or a spring. Gravity is a force of attraction between two masses. So for example, yourself and the Earth, each pulls on each other. And then normal reaction force is a force which acts perpendicular to contact. So we have two contact forces here, the normal reaction force, which is perpendicular to the contact, and the frictional force, which resists motion in the opposite direction to which the two objects in contact are trying to slip over each other. Question 5. So the force here, so a force diagram is something you need to work with, particularly in the second year. And you need to be able to draw these force diagrams and label them. So in this case, we have a force diagram of a block sliding down a slope. So although it's sliding down the slope, and so the velocity is down the slope, we're actually asked to label the forces. So what are the forces on here? Well, the possible forces are tension, thrust, normal reaction, weight, mass, and friction. So the first one, A, you should realize is a weight force because it acts vertically downwards. The second force, B, is a contact force which resists motion. So if this block is slipping down the slope, it's moving down the slope, so the friction force will act parallel to the contact, but up the slope so as to resist the motion. And then the normal reaction force, C, is perpendicular to the slope, and that's to do with the contact that the block feels from the slope. if we're looking at forces on the block. If we're looking at forces on the slope, then the slope would feel a normal contact force from the block, but it would be in the opposite direction. Question 6. The height h in meters above sea level of a stone thrown from the top of a cliff at time t seconds after it's thrown is modeled by this equation. And we'll see later how to derive equations like this, but for the moment we just need to use it. State the height of the cliff above the sea level. Well, we're told that h represents the height t seconds after it's thrown. So when it's thrown is when t is 0. We put t is 0 in here, we get that h is 80 meters. So at the beginning, this stone is 80 meters above the sea level. Find how many seconds after being thrown the stone hits the sea. Well, when it hits the sea, because h is above sea level, will be when h is 0. We solve the quadratic. We get two values of t, one positive, one negative, but clearly t has to be positive because it doesn't hit the sea before you throw it. And so we get the answer, which is about 5.123 seconds. And now some vector work. Question 7. Miranda walks from A to B and then B to C. So coordinates of A are 1, 2. The coordinates of B are 5, 5. And then the displacement from B to C is given by the vector 5i minus 6j. In other words, getting from B to C, we have to walk 5 in the I direction, that's the positive x direction, and 6 in the minus j direction, which is in the minus y direction. Find the magnitude of the displacement from A to C. Well, displacement is a vector, so we just get the vectors of going from A to B. And going from A to B is going to be 5 minus 1, which is 4, 5 minus 2, which is 3. So the vector from A to B is 4, 3. We're told the vector from B to C is 5 minus 6, and if we add them together, 4 plus 5 is 9, 3 plus minus 6 is minus 3. So the displacement is 9 minus 3. And the magnitude of the displacement, which is distance, is the magnitude of this vector, which is 9 squared plus minus 3 squared square rooted, which is about 9.487 meters. The total distance Miranda has walked from A to C via B. Well, Miranda's walked from A to B, and the length of this vector is 4 squared plus 3 squared square rooted. And then from B to C, which is 5 squared plus 6 squared square rooted, if we add those two together, we get about 12.81. So notice there's a difference between the displacement from A to C and the distance that actually Miranda walked in going from A to C, because it didn't walk, Miranda didn't walk in a straight line, walked from A via B to C. Indicate which of the following are scalars: velocity, speed, weight, mass. Well, the speed and mass are scalars. Velocity and weight are vectors. Vectors have magnitude, but they also have direction. Occasionally people refer to just the magnitude of velocity, talk about a velocity of 2 meters per second, but in general velocity is a vector. So it has maybe 2 meters per second in a particular direction. And likewise weight. Weight is a force, so you can have a weight of 10 newtons, but actually it's 10 newtons vertically downwards. Okay, that's it.